Imagine stumbling upon a cosmic traveler that's journeyed across the vast emptiness between stars for possibly billions of years, only to find it's erupting with icy volcanoes right in our solar system. That's the thrilling reality of Interstellar Comet 3I/Atlas, and it's sparking debates about the origins of life and planets beyond our own. But here's where it gets controversial. What if this visitor isn't just a frozen rock, but a clue to a universe where alien worlds form in ways we never imagined? Stick around, because this discovery could rewrite what we know about space. And this is the part most people miss, the hidden volcanic activity that might reveal secrets from distant stars. Published yesterday, 16/230. Interstellar Comet 3I/Atlas seems to be undergoing cryovolcanism, mirroring peculiarities of outer solar system bodies. Fresh findings indicate that this interstellar guest might be a primitive carbonaceous object, complete with ice volcanoes. James Felton. James is a published author with multiple pop history and science books to his name. He specializes in history, space, strange science, and anything out of the ordinary. ***. Senior staff writer. James is a published author with multiple pop history and science books to his name. He specializes in history, space, strange science, and anything out of the ordinary. View full profile, https://www.iflscience.com/James-Felton. James is a published author with multiple pop history and science books to his name. He specializes in history, space, strange science, and anything out of the ordinary. View full profile, https://www.iflscience.com/James-Felton. Edited. https://www.iflscience.com/editorial-mission-statement. By Laura Simmons. Laura holds a master's in experimental neuroscience and a bachelor's in biology from Imperial College London. Her areas of expertise include health, medicine, psychology, and neuroscience. A recent preprint study, which compares the comet spectra to untouched NASA samples collected from Antarctica, suggests that Interstellar Comet 3I/Atlas could be a primitive carbonaceous object. Not only that, but this third known interstellar visitor appears to be in the midst of cryovolcanic activity during its unprecedented close pass by our Sun, one that hasn't happened in maybe 10 million years. For context, think of it like finding an ancient artifact from another civilization, but this one is alive with activity and could unlock mysteries from the early universe. While a lot of recent discussions have centered on the chance that 3I/Atlas might fragment as it approaches our star, an international group of researchers has focused on viewing it as an ancient survivor. Earlier research indicates that this object, one of only 3 interstellar visitors we've detected, has likely endured the harsh conditions of the interstellar medium, ISM, bombarded by cosmic rays for potentially billions of years. This survival suggests it must have extraordinary durability. From a cosmogonic perspective, any body that lasts so long in the unforgiving ISM needs significant mechanical strength, the researchers note in their paper. Observationally, 3I is also sizable. Its diameter is estimated at 0.3 to 5.6 kilometers, and its roughly 16-hour rotation period helps evenly distribute solar heat across its surface. They add that its speedy inbound trajectory implies it was hurled out during a near miss in its original planetary system. Even though no recent stellar close calls have been spotted within 500 parsecs, earlier encounters remain possible. These factors lead the team to propose that 3I/Atlas might be a carbonaceous body rich in metals. Scientists determine the makeup of small solar system bodies by analyzing the light they reflect, breaking it down into spectra, a process called spectroscopy. To explain this simply for beginners, imagine light as a rainbow, where each color band reveals different elements. For instance, hydrogen creates its own unique bright lines, different from helium or carbon. This technique lets astronomers identify what's inside stars or comets without touching them. In this unreviewed study, the team analyzed photometric data from 3I/Atlas and matched it against pristine carbonaceous chondrites from NASA's Antarctic meteorite collection. These meteorites, hunted in Antarctica since 1976 through NASA's ANSMET program, are like time capsules from space. The spectral comparisons showed striking resemblances to Trans-Neptunian objects, TNOs, those distant icy worlds beyond Neptune's orbit. The spectral matches suggest that 3I/Atlas could be a primitive carbonaceous object, possibly loaded with native metals and showing signs of intense water-based changes as it nears the Sun. The researchers write. They further state that it's undergoing cryovolcanism, just as we'd anticipate for a fresh Trans-Neptunian object. We suggest that the mix of high metal content and plentiful water ice explains the peculiar shape of its coma and the unusual chemical substances observed so far. Now, cryovolcanism might sound like something from a sci-fi movie, but it's not unusual for TNOs. Essentially, it's when materials from beneath the surface burst out, like volcanoes but made of ice. Researchers have seen this on moons orbiting our gas giants and even on TNOs like Pluto, where supercold eruptions reshape the landscape. Studies of TNO interiors show that cryovolcanism could be a common geological activity on bigger ones, over 800 kilometers in diameter, especially around the outer planets. Even though 3I/Atlas measures 0.3 to 5.6 kilometers, smaller than those giants, the team thinks this behavior fits for a TNO warming up near the Sun. The roughly 2 magnitude brightness boost at 2.5 astronomical units, followed by the swift growth of a hazy coma, points to the awakening of volatile substances near the surface, they explain. This even occurs when full water ice sublimation might not have kicked in, perhaps only in the subsurface due to localized heat and pressure. Cryovolcanism happens on fresh, ice and carbon-rich bodies in the outer solar system, and 3I's actions closely mimic what we'd expect from a pristine TNO nearing the Sun. To delve deeper, corrosion of tiny metal particles could spark energetic Fischer-Tropsch reactions, producing specific coma chemicals that aren't typical in other comets. Why? Most comets originate in the outer solar system without inheriting much metal. Beyond the sheer awe, this is an interstellar comet with space volcanoes. This finding helps us understand worlds orbiting other stars. Though its origins lie in an unknown extrasolar environment, 3I shares the closest spectral ties with Cr and Ch chondrites, which have bland red spectra, probably from metal grains, sulfides, and other dark materials. The team clarifies. This implies that the initial phases of planet formation might yield comparable substances, even in far-flung galactic corners. Spectroscopic analyses are invaluable, but the researchers emphasize prioritizing missions like ESA's Comet Interceptor, aimed at sampling future interstellar objects directly. Visitors like 3I/Atlas push the boundaries of our knowledge on how planetary systems assemble and how small bodies evolve chemically. They conclude, each new find uncovers surprising traits that challenge existing theories. Upcoming interception missions will be crucial for approaching and sampling these rare envoys, decoding the histories from remote solar systems. The study is available on the AR-14 preprint server, https://arcs4.org/abs/2511.19112. But wait, is this comet really so similar to our own solar system objects? Or could it be evidence of completely alien chemistry? Some might argue it's just a coincidence, while others see it as proof that life-building materials are universal. What do you think? Does this mean we're not alone in the cosmos? Or is there a controversial twist here that suggests interstellar objects are weirder than we think? Share your opinions in the comments. I'd love to hear if you agree or disagree.